So this was a last week homework exercise that was related to the amount of the substance. I'll go through the pages. You can just let me know if any doubt you have, any specific part. Page number 2. Any doubt? Page 2. Page number 2. Any doubt? Okay, page 4, because page 3 was only one part was there. Page 4, any doubt? No? Part E. So we have the salts. Gullible salts is a form of hydrated sodium sulfate that contain 44.1% by mass of a sodium sulfate. Hydrated sodium sulfate can be represented by a formula Na2SO4 dot XH2O, where X is an integer. And we have to calculate here like the moles, the number of the moles of the water molecule. So how it can be done? It's the same way how we work out the empirical formula. So 44.1% by mass of a sodium sulfate. So if we have Na2SO4 and water will be there, H2O. So this is 44.1%. So how much is, what will the percentage of the water by mass? Because total sum should be 100. So if I subtract 100 minus 44.1, so I will get 55.9. Now first what we do, we divide it by the atomic mass or a molar mass of 1 mole. So mass of a 1 mole of sodium sulfate, sodium is 23 multiplied by 2, 46, and oxygen is 16 multiplied by 4, so 64, and plus sulfur is 32. So the total mass will be around 142, and this will be 80. So when we divide, this will be 0.310, and this is 3.11. Then we divide by the smallest value in the combination, so 0.31 and 0.31. So this is 1 and this is approximately 10. So what is the value of X? The value of the X should be 10. Is it clear? Then page number 5, any doubt? Page 5, 4B. Okay. Write an equation for a reaction between a silicon and nitrogen to form silicon nitride. So the final product is silicon nitride. Silicon, like group 4 element, because they have the tendency to form a long chain compound or cat. So what we call, they exist as an atomic, like metals or group 4 element, as they can form a long chain compound, they will be atom. So we'll have a silicon atom. And nitrogen is a simple molecular structure. So how it exists as a diatomic molecule, it will be N2. Now we just have to balance this equation. We have 3 silicon, so we put 3. Silicon is balanced. And we have 4 nitrogen, so we put 2. So the nitrogen is also balanced. The states, silicon is solid at room temperature, nitrogen is a gas, and this compound of a group 4, it should be solid. Question 5, any doubt? Any specific part of the 5? Five part A, B, C. Said why it is important to fill the space below the tap in the burette with the solution A before beginning of an accurate titration. So what actually happened? So what we have to do, because when we fill the burette, we add the liquid, the solution from the top. When we add the liquid from the top, so the burette traps some of the air. So some of the air is trapped here. So why it is important to fill the space below the tap, like this whole space in the burette with the solution A before beginning an accurate titration. Otherwise, what might happen when we open the tap, first the air will come out and then the liquid will come out. So we will get an inaccurate value of the volume of a liquid which is removed. So it is always important that the tighter value, we remove all of the air by filling up till the opening of the tap, so that there is no air present. Otherwise, practically the tighter volume will be different as compared to what we are using. Is it clear? So you can just mention the tighter or volume added. It will be too high if we don't fill it. Suggest one reason why 250 cm cube conical flask is preferred over a beaker. So the purpose of the conical flask, so we can easily swell the mixture. Like, because the opening, the mouth is so narrow that the liquid, when we swell the mixture, it will not come out. But when we swell the beaker, the chance is that the liquid might come out. So the possibility is there that while we are swelling, the liquid might splash during this, or liquid does not splash in a conical flask when we swell as compared to that of a beaker. Then during a titration, the chemist rinse inside of a conical flask with a deionized water. The water used for rinse remain in the conical flask. Give one reason why this rinsing can improve the accuracy of the endpoint. So what actually happened if we rinse the conical flask and not all of the water come out, some of the water is still there. And then we fill it with an acid. So what will happen to the concentration of this acid? The concentration of the acid will decrease. So how it will be in, yeah, deionized water will not take any part, but what might happen, why it will make it accurate? Because see, when we swell the mixture, when acid and alkali are reacting and we swell the mixture, so some of the acid might be there or some of the alkali might be there in with the wall of the container. So when we rinse with a distilled or deionized water, so all of this is added to the solution, mixed with the solution. So advantage is that the reagent or the chemical which was there on the side walls of the flask will return to the mixture, and we can make sure that all of this will react. That's the advantage of washing with a deionized water. Is it clear? It won't affect it won't affect the moles, but the concentration will become aware. There will be a slight change in concentration of the solution, but it won't affect the number of the moles. And for the second part, Explain why the water used for the rinsing has no effect on the accuracy of the titer. Because the total moles are not changing. What only happen is, say you was having a conical flask and the solution example was having 2 moles inside. When you add a deionized water, and wash or rinse, that water will also mix here. But that water will not affect the moles of the acid or the moles of alkali. So by rinsing with the water, it does not affect the moles of acid or moles of alkali. That's why it will not have any effect on the titration. Is it clear? Next is page 9. 6A and B. State the ideal gas equation. So what is the ideal gas equation? PV is equals to nRT. Then there are several methods. Ethanoic acid synthesize. Balance the equation. So combustion here C4H10 plus O2. So if we want to balance this equation, if it is a combustion equation, we try to balance with carbon and then followed by hydrogen at the last oxygen. So if I have 4, if I put 2 here, carbon is balanced. Because first I put 2, so the carbon is balanced. Then hydrogen 10. So 3 multiplied by 2, 6. Like here we have 4 are there. And 4 multiplied by 2, that will make 8. And 8 plus 2, 10. Hydrogen is balanced. What about oxygen? This 2 oxygen multiplied, so 4 oxygen here. We want to balance the oxygen number because here is 2. 2 oxygen multiplied by 2, total 4 oxygen, 5. So how I can have a 5 oxygen? So if I put 5 by 2, so this equation will be balanced in terms of all. Or if I need the whole number, I can multiply all of them by 2. So this will become 2C4H10. Then it will be 5 because 2 will cancel. This will become 2 multiplied by 2, 4. And this will become 2. So both are right. I can use a fraction or I can use the whole number. Page 10, 11 or 12, any doubt? 9A2. Thymol blue is an acid state. How the average titer would change if a few cm cube rather than few drops of indicator were used by mistake. So look, the indicators are also having a nature acidic or alkaline nature. So if the thymol blue is acid and we add few cm cube rather than drops. So as a result, for a neutralization, what we need more alkali. Because acid is already there, plus the indicator which is also acidic. So the solution will become more acidic. So we need greater amount of the titer value, or more titer is needed. Less than a minute left, so I'll share another link and discuss the remaining.